Welcome to this session, Collaborative Resource Sharing and Supply Chain Models for Biotech Education. We have two great speakers today, Kristen Walslegel and Ying-Soo Lo. Kristen has been the Executive Director of BABEC, which is the Bay Area Bioscience Education Community, since 2015, and she's also a faculty member in the Biotechnology program at City College of San Francisco. Ying-Soo is the Associate Director at BABEC, and she oversees the BABEC team and provides leadership on BABEC's collaborative projects with educational and other nonprofit partners. And I will stop sharing my screen now and let Kristen take over.
Great, thank you for the introduction, Lauren. Thank you for the opportunity to talk about the work we're doing at BABEC in this forum today. We're excited to be part of this groundbreaking first annual Biocom Education Symposium. And I'm going to share my screen now. Hopefully it will work. Let me try that again. Okay, can you see that okay? I'm hoping everyone can see this. Please chime in and let me know if it is not visible. So this session will be split into two portions, each displaying two different models for how BABEC is supporting biotech education. I will talk about collaborative resource sharing, and my partner in crime and Associate Director BABEC, Ying-Soo Lo, will talk about supply chain models. And then we hope to leave several minutes at the end for questions and discussion. So the Bay Area Bioscience Education Community, known by the acronym BABEC, is a teacher-serving organization. We've been operating in the Bay Area for 25 years, and our mission is to inspire all, capital ALL, students to engage in science by empowering teachers. And I emphasize the all because our core reason for existing is to lower those barriers to access for relevant, current, hands-on biotech education. And we have a model that is accessible to any teacher at any school at any level of knowledge and resources. Teachers are our primary service recipients. We can reach exponentially more students by working through and supporting their teachers. And the primary teacher population that is the focus of our work is the general biology and general science teacher. We do support biotech teachers and advanced placement and honors bio teachers, of course, but all of our resources are designed to serve as that very first touch point that a teacher and thereby a student can have with biotech learning. After the initial exposure to biotech that we offer students, it is our sincere hope that they can then enroll in advanced biotech courses and get in a pipeline to career in our industry. So BABEC operates at that very beginning of the student career pipeline in biotech. Our hope during this talk is that listeners will see how this model that we will share with you can be implemented in your local regions and communities, and you'll seek to partner with us to expand this model into regions where we're not currently serving. So having said that, I'll hop right into the overview of what we do. So BABEC supports biotech education with what we call 4 legs of the lab bench. Our 25 years of experience has permitted us to identify what we call the 4 key pillars of support that are needed to make hands-on biotech lessons accessible and inspiring for all types of learners in all types of classroom settings. So what are these 4 legs? We offer curricula that's been developed by teachers and is industry relevant. We offer reagent kits that are organized for easy and straightforward successful classroom use. We have laboratory equipment loaner kits that leverage the power of shared resources, and we have professional development opportunities for teachers in a variety of modalities that is accessible when they need it. So the next 4 slides, I'll walk you through these 4 legs of the lab bench in detail that are needed to support quality and accessible public biotech education. So curricula, we offer a wide range of lessons covering the basic skills competencies that are needed to conduct biotech labs in the classroom, followed by introductory DNA analysis using polymerase chain reaction. We have genetic engineering labs where students can isolate a recombinant protein. And we have some new COVID-19 lessons around how diagnostic testing for COVID works, and also lessons on global pandemics. Each of the lessons includes a complete set of both teacher and student-facing resources that help to easily integrate real-world biotech experiences into a classroom. Our curriculum is written by experienced high school biotech and bio teachers and is a comprehensive full support package of resources that can include many things such as detailed lesson plans. If you're new to teaching biotech and you've never done it before, we have a lesson plan that tells you what to do down to the minute. So you've got absolutely everything you need for classroom success. That includes instructional slides, student worksheets, pre-lab activities, resources for English language learners, youth-vetted protocols that are designed to work with a classroom of 30 teenagers. Here's an image of a couple pages of our student-facing protocol. It has straightforward instructions, complete with illustrations that help optimize successful classroom results. We also have clear guides for teachers to help them set up their classroom, take all that guesswork out of reagent and lab station prep. And then we have technical and troubleshooting work support available both online and in person by the BABEC staff. It's pretty much anything that a teacher has ever asked for over the 25 years we've created. And the reason this talk is titled Collaborative Resource Sharing is that we feel our curriculum resources can only be useful to teachers if we collaborate closely with them. So we listen to teachers in the field. We observe how they're using our materials in the classroom, and we constantly make adjustments along the way so that we can give them exactly what they need. This kind of teacher-centered support, we feel, is the key to successful biotech education. Moving on to the next leg of the lab bench to support biotech education, equipment kits. So the core service that BABEC was founded on, this idea of leveraging the power of shared resources, really lies in our equipment loaner kits. Lab equipment is expensive and entirely out of the reach for most schools. So we solve that problem by curating and delivering all of the necessary supplies, laboratory equipment, and consumable items to teach each of those lessons that you saw in the previous slide. We have a full classroom kit or a la carte options. If you look at the lower left portion of the slide, you see 12 bins. Those are a big kind of 2-foot by 3-foot Rubbermaid bin. 12 of those in your classroom gives you absolutely everything you need to teach a biotech lesson, even if you're starting from zero. But now, 25 years later, we've learned that teachers actually do already have a lot of these supplies already in their biology classroom. So maybe they just need 1 or 2 things, like a classroom set of micropipettes, for example. So you see 3 small bins of pipettes, and then we offer everything in between. We have hundreds of thousands of dollars of biotech equipment in our inventory. Much of it has been donated charitably. So I'd like to thank our donors over the years, BWR and LabCon, that have contributed a lot of in-kind to support our kits. So part of our inventory right now is we have 1,200 micropipettes. We have 200 electrophoresis rigs, and we have consumable supplies. We estimate we go through about 400,000 microtubes every school year, for example, and twice that in micropipette tips. So delivering these kinds of kits to teachers in classrooms is a huge logistical lift, but it is what it takes to get the job done. And it is decidedly not glamorous. We do a lot of schlepping, but it is exactly the kind of core service that is needed to provide this support for schools, teachers, and students. The next leg of the lab bench is reagent kits. We have a biomanufacturing laboratory located at our partner institution, City College of San Francisco. And that is where we make all the reagents needed to teach the written curricula. The reagent kits are researched, optimized, prepared, packaged, and quality control tested by experienced lab staff, and then they're aliquoted and labeled in classroom-friendly volumes. Again, we've listened to what teachers need, and we do a lot of the prep work in advance for them, and it shows in our reagent kits. I'd also like to mention that many of the enzymes, buffers, and lab chemicals that go into our reagent kits have been donated by our sponsors. And you see a list of our in-kind donors at the bottom of the slide here. I particularly like to call out Thermo Fisher. So 25 years ago when BABEC was founded, Applied Biosystems, the thermal cycler company and PCR reagent company back then, they were independent, and they were one of the early founders and supporters of BABEC. For the last 25 years, Applied Biosystems, now Thermo Fisher, has supported our work by giving Taq polymerase, DNTPs, all kinds of buffers for our PCR programs. I'd also like to mention that we have close partnerships with community colleges. So over the last 5 years, we've hired 9 community college biotech graduates from community college programs to work in our lab, either as interns or as permanent employees. And the BABEC laboratory serves for these students as their very first job experience, paid entry-level laboratory technician job experience in biotech. And many of them have then gone on to work in industry. So I'd like to just close on our reagent kit side by saying that during COVID, these reagents have been sitting anxiously awaiting in our freezers. And you can see in the upper left, your classic white freezer box with vials of PCR master mix and primer mix and control DNA waiting to go into the classroom, hopefully this fall. And then the final leg of the lab bench for biotechnology education support is teacher professional development. So we provide a wide variety of opportunities throughout the year for teachers who may never have had the chance to do hands-on science in college, or if they simply want to brush up on skills they learned a long time ago. So our trainings are designed to be flexible and to meet teachers where they need it most. And just like everything else we do, we've listened to teachers, we've collaborated with them, we've heard what they need, and we have a wide variety of services. In COVID, we did a live online workshop series. We have our traditional Saturday hands-on workshops that will resume come next school year. We have a large annual fall conference. We'll do after-school small group sessions. If your science department wants us to come by for an after-school training, we'll do that for you. We do one-on-one skill sessions with individuals. We'll do in-class logistical support. So we'll show up in a classroom if a teacher has never taught at Biotech before and would like us to be there to help with all those little details. We have online office hours. We'll do district PD if you invite us. And then something new this past school year during COVID school closures was something we call coffee curriculum collaboration. And occasionally we'll throw a cocktail or two in there. It's an Friday afternoon happy hour where we invite teachers from around the Bay Area to get on Zoom with us and talk shop and get to know each other and just decompress on anything they want to talk about, biotech education related or otherwise. And so I like to say that the C in BABEC stands for community, and it is our teacher professional development services that really bring out that community. And we found that one of the most valuable services we provide to teachers is the opportunity for them to meet colleagues at different schools and to realize that their struggles and challenges, they're not going through alone. There's other people, and we can bring us all together to get the job done. So that's the BABEC tried and true method that we call the 4 pillars of support, 4 legs of the lab bench for biotech education. But how is that translated into impact? Does it actually work? Over the last 25 years, you can see some of the highlights of what we have successfully brought to the community. So we've served well over 5,000 teachers, independent teachers in the last 25 years. We've estimated that we've delivered 30,000 laboratory kits to classrooms across the Bay Area. And so each kit serves approximately up to 40 students. So if you calculate on an average class size of 30 students, we estimate that well over 800,000 students have been directly impacted by the work we do by having the opportunity, oftentimes the only opportunity, to do hands-on biotech labs that they may not otherwise have had the chance to do. I'd also like to highlight that we have 48 ongoing collaborative partnerships. The second half of this presentation is going to go into some of the partnership work we're doing. But again, I just want to emphasize that we love collaborating with the community. And if you have any ideas you'd like to bring forward to us, we are all ears. And then also emphasizing on that note of building collaborative partnerships. We're currently active in 9 counties in the Bay Area region. We've recently initiated collaborations with a lot of community colleges in Southern California as well. And we're also now, for the first time ever, supporting teachers with our curricula and lessons in 11 other states nationwide. So what's next? What I've described so far is the core BABEC service of supporting high school teachers in the classroom and high school students with hands-on labs. But we have several new initiatives underway. We're now into our 3rd decade, and we're continuing to grow, and we're continuing to evolve and adapt to the world today. So BioSCOPE is a program that Ying-Su will be talking about shortly. I'll leave that to her. We're also involved with a national initiative called Innovate Bio. It's the National Biotechnology Education Center. It's based at Austin Community College. It's funded by the National Science Foundation. And it is a national group that traditionally has composed of community college biotech programs, but BABEC has been brought in to provide the high school piece, because there are important pipelines that need to be generated between high schools and community college for technician and workforce level job training. And we're thrilled to be part of that new national initiative. And then we've been invited by Genentech to be part of a new program. I'd like to give a shout out to Eileen Yang, who I believe is presenting at the next session right after this about the new Genentech initiative. And I'll leave that up to Eileen, but I'd like to also emphasize that BABEC is thrilled to be part of that new initiative. And then I'd like to close by putting a call to action out to you all. We're in the Bay Area, but we're more than the Bay Area. And we've been invited by so many people to bring our model. Our model is translatable, these 4 legs of the lab bench. Anybody can do it. We've got a playbook that we can share with you. So we'd like to ask you, if you're interested in becoming a BABEC teacher, sign up with us online. If you have ideas about how we can partner together, if you're an industry group and have a program you'd like to implement, if you're another nonprofit and you want to collaborate, reach out to us. If you'd like to volunteer on curriculum or helping in the classroom, let us know. And finally, we are recruiting board members. So if you'd like to provide strategic input in some way, do reach out to us as well. That is our generic email, babec@babec.org, which is a good way to reach me. And you can go to our website, babec.org. So that is my very quick overview of what BABEC does. Before passing it on to Ying-Su to talk about BioSCOPE, I'd just like to ask Lauren if there are any questions at this time. And if not, we'll jump right ahead.
Yeah, you mentioned that BABEC has a presence in Southern California, and someone asked specifically about Orange County.
I think for Orange County, I believe Ying-Su can speak to that. There are some faculty at the local community colleges that we're working on with our BioSCOPE program.
Yes, so we do have a supply chain guidelines project with multiple community college members, and one of them is in Orange County. And so just reach out to us and we can give you more details, and we can also talk about how we can work with you further.
Okay, so if no other questions at this time, Ying-Su, I'll advance the slides for you.
Okay. Great, thank you very much, Kristen. We're going to take a little bit of a switch and go deeper into one of our projects that we work on, which is called BioSCOPE. I will cover today some brief background on supply chain, and just for a change, because the chat on my Zoom is a little bit quiet. If you've heard of supply chain, you can say yay on the chat and let me know. Otherwise, I'll give you a little bit of a background on supply chain and our own flavor of supply chain that we practice in the Bay Area called BioSCOPE, the Biotechnology Supply Chain Operations Projects for Education, and how we're increasing access to hands-on science via our partnerships with multiple community colleges. And I hope at the end, what we can come out of this is how BABEC can serve as a bridge between high schools and community colleges through these partnerships and collaborations, because that's what this title of this talk is about, collaborations and partnerships. So next slide. So just a brief background on supply chain. Supply chain is really a network between multiple companies and its suppliers. So here is a really broad overview of raw materials coming into the supplier, where they get manufactured and then get distributed to customers, and then finally to consumers. And so there's also much more granular examples of supply chain. And if you're into toilet paper during the pandemic, you can think about, well, toilet paper, where is that paper coming from and where does it have to go? And I think part of the toilet paper dilemma was also packaging, where you can package a large number of rolls that go to warehouses, or you can package a few rolls that go to stores. And so that was part of the whole supply chain during the pandemic. We also heard about that barge that got stuck at the Suez Canal and how that disrupted the supply chain. So I hope that you guys have, maybe your ears have perked up. I know mine has, with the word supply chain, because it's being used a lot these days with biotechnology. Next slide. So I cannot leave supply chain without talking a little bit about the vaccine supply chain. And maybe this comes in closer to you in understanding what supply chain is. So in order to produce vaccines, we do need those glass vials. That's shown a lot on media, how they're labeled with COVID-19 vaccines. Well, we need the glass vials to go to the manufacturer, where they're using those raw materials to make the vaccine that goes into those glass vials. Those glass vials have to also go into refrigerators, stored in warehouses. There are certain parts of the United States where those vaccines are stored. And we all know that it needs to go into really low temperature refrigeration, freezer really. And then from there, it gets distributed to hospitals, clinics, Walgreens, Safeway, whatnot, so that it can go out to customers. And that's us. Or actually, it could be us, or it could be also those bigger companies that are going to be distributing it even further out to the consumers. Lucky for us, we are about 50% vaccinated across the whole United States. And once we reach about 77%, I think we have then herd immunity. So this is just an example that I hope you can understand where supply chain fits. Next slide. So now we have our flavor of supply chain, which is called BioSCOPE, where we get orders from high schools. Those orders then go into all these different community colleges to help us produce those reagents. And when I say orders, we're talking about those reagents that Kristen talked about. We have those baggies of tubes and multiple tubes and multiple bags. And it's a lot of work. Actually, the logistics wise of putting those things together is a lot of work. And luckily, we have these community colleges to help us put those kits together. Here you see also Skyline College, where they have a pretty nice facility and to make or pour plates for us. For some high schools, plates for, say, for example, bacterial transformation is a barrier to teachers doing hands-on science or doing some biotechnology. And so we reduce that barrier by providing those already poured plates for you. Next slide, next, Kristen. Okay, there we go. So there's me in my car trying to deliver that to our customers. And next, where it will go into the classrooms, who are the consumers, and where now these are high school students who are able to practice those experiments. If you are a high school or community college, we are working on pathways from the high school to the community college, and then finally to the workforce or to further education. And we want students to be aware of biotechnology. And that's one way we can bring hands-on science into the high school classroom, while also having the community college students practice some of those manufacturing or production practices that industry wants and needs right now. So we get results and for assessment. Next slide. So in this, you'll notice that my last several slides are talking about the supply chain, and I hope you see this interconnection between this chain. So bringing in another piece of this connection and link between community colleges and high school. In the BioSCOPE project, we have community college teachers and students that work together to prepare and quality test reagents. It's in a very much more granular sense. In order to make those reagents, they also have to calibrate and validate equipment, for example, and make sure that those reagents are going to work well through quality testing. So our products are highly robust, in other words. So then it goes to the high school teachers and students who are able to use those products in their labs, in the labs that we produce in our curricula as well. And there we go. So what did the community college students gain? They gain some relevant workforce skills. They have much deeper ownership of products. They gain also leadership skills. And there's also a loop involved too. So we can close that loop by going to the high school students. The community college can also do some recruitment for their colleges by going to the high schools and also teaching them about what the community college hands-on biotechnology is all about. It's creating these accesses for high school students at their high school, but also having them aware of what biotechnology is through those practices and through the community college interactions. Okay, next. Okay, so in the community college sense, what we have are simulated work environments. Students are producing useful products. And those products can range from anything like buffers to, of course, plates, to plasmid isolation, to proteins. There's projects out there that are working to make DNA polymerases like TAC. So in a sense, it's mimicking a manufacturing environment. Students are getting hands-on practices. They're working collaboratively. They have documentation. So as you can see, all the words that I'm using are all those skills that are needed for workforce. Here you also see an emphasis on quality. That's through the core of our practices here: quality control, quality assurance. What you see there in the graphic is a fishbone diagram to look at some root cause analyses. And we have also sort of corrective procedures as well if something goes wrong. So all these are ideas that students are learning about at the community college level. Next slide. Okay, just some pictures to show you some of the students here that are practicing BioSCOPE here. So on the left side, you have a large plate pouring session, and she's just, the student here is lining up all the plates here to show all the plates that she's pouring. On the upper right, we have validation of an autoclave to make sure it's working properly. On the bottom right here, we have a student quality testing some plates to make sure they're working properly. In the middle here, we see a restriction enzyme digest of some plasmids that have been extracted. And then on the bottom left, I always like to show this picture and see how serious these students are in double checking the work that the introductory biotech students are doing in their classroom. So these are quality assurance agents at Skyline College, quote unquote, so that they make sure that all the work that's being done by the intro students in producing those products are done well and following SOPs. Next slide. So if you're a high school working with us, you might have seen some of these products that are here. We have some buffers that are made, lysis buffers and calcium chloride for transformation, for example. You may have seen some media bottles, LB agar bottles. Sometimes teachers like to pour their own, so we allow that to happen. In the middle there are our sleeve of LB agar plates. We also provide some Chelex tubes for DNA extraction. For those of you that have isolated DNA from cheek cells, that's something that looks familiar to you. Believe it or not, aliquoting you might think is easy, but aliquoting Chelex beads are actually difficult because you have to make sure that each tube gets those beads at a certain amount. So students have to check visually to make sure that those tubes have something in them, and as well as the beads. In the middle there, you see some plasmids that have been isolated that's been aliquoted out. So it saves us quite a bit of money, which we then pass on the savings to the classroom, the high school classroom as well. Next slide. So here's some data. We're all interested to see what that data is like. In terms of the community college students that have participated, over 200 in the 2 years that this program, just a snapshot really, because this project has been around for 4 years. And the student participants are learning, a lot of skills that we say is priceless. Education is priceless to us. Number of hours in a project, over 1,000. Calculated by what you see below, number of hours times $18 an hour for their time and effort. And some of our biggest products here: agar plates, Helix tubes, bottles, plasmids. And the number of high school students served is about 17,000. So you can see that, the number of community colleges here, about 8 community colleges that work with us, are providing that much many resources at a low cost to these high school classrooms. And that's priceless to us. If 17,000 students are having some hands-on practice in biotechnology and allowing them to be much more aware of what biotechnology is, that's a priceless knowledge there. We're happy to say that the NSF logo there is reminding me that the data that we produce here also allowed us to get an NSF grant recently. So we also have what we call the ATE BioSCOPE through the Advanced Technical Education that specializes in workforce training. And so the last 4 years, the California community colleges have helped fund this project. Now that that fund is sunsetting, we are now moving on to an NSF funded phase of our project, which is tremendous for us. Next slide. So you might ask, so what happened during this pandemic while everyone was at home and doing virtual Zoom lessons and virtual Zoom meetings? Well, lucky for us, we also had a project going on that was also funded by the California community colleges. We decided that, students, it would be good for students to understand more about the COVID-19 pandemic and how to actually test for that. And we decided on 2 different tests for this, the ELISA test and also a strip test, much like a pregnancy test. And so we put together a mock COVID-19 ELISA and rapid test kit that you can see here. On the right are all the contents that are in this kit. And on the left is what the community colleges were able to put together in their BioSCOPE project. So we combined 2 projects in one by having this COVID kit and having BioSCOPE students put the kits together. And those kits were then able to go out to many community colleges, some dual enrollment high schools as well, and practice some ELISA, some pipetting using transfer pipettes, as well as the rapid test or strip test, similar to a pregnancy test. And what we're doing here is mimicking a mock COVID test so that students understand more about what that means. You might be curious to understand how you can see or how you can analyze an ELISA plate. I'm happy to tell you that there's a free app out there that you can use to do some microplate reading. And I think that changes this whole accessibility of doing ELISAs at home or even in classrooms that don't have microplate readers now when we go back to the classroom. Next slide. So I hope that what you're able to see here is that BABEC is poised. We are right now serving as a bridge between high schools and community colleges. We work with both. We understand the language of both sides in that we work closely with high school teachers and districts and administration. We also work closely with the California community colleges faculty, as well as the regional and statewide directors for Biotech. And we are national now. We are part of the National Center for Biotechnology Education. I hope from there that you are excited to work with this. If you are a community college faculty, ask us about the guidelines project for supply chain and how you can incorporate supply chain into your course. And what we're really excited about is doing some pathway work with you. How do we connect the high schools in your area to increase enrollment and have students be aware of your biotech program? If you're a high school teacher, ask us about working with us, being a BABEC teacher. There's no membership charge. We do have free curricula out there. And then we can talk about charges for other services. If you are industry or trade organization, we have a task force that has an advisory board that you can help us learn more about supply chain and how it is used in industry. You can also help sponsor biotech education. And we want to work in areas that are especially underserved. And so we can bring all these experiences to those students and those teachers and those communities at no cost to them. And then how can we collaborate more to target any bioscience curricula that's more state of the art, for hands-on learning. So there's a lot of different ways you can communicate with us on that. Here are our emails, and you can go to the next slide. Thanks. So thank you for listening to us. And if you have any questions, I'll take questions. So Kristen and I can answer your questions, and there's our email there.
Thank you. We have one question. You mentioned an app. Can you tell us what the name of that app is?
Yes, it's called SpotXL. It's available for Android and for iPhones. SPOTXEL. Okay. So I didn't see the chat. Did anybody answer yay to the supply chain question that I have?
Would you mind asking the question one more time, and then we'll give everyone a chance to type in?
Sure. My question during my talk was if anyone has heard of supply chain, to say yay on the chat.
Yes, we did get a few yays coming in. Several people have heard of it. All right, we have another question. Are your services going to remain free or at low cost?
So we have, we're coming up, Kristen, would you like to answer that? Or do you want me? Okay, so right now we are switching on to a new website platform. Next year, all our curricula in the past, when we were doing hands-on, has been free. What we do charge are for reagents and for equipment rentals. We have to pay for our staff and for our core programs. So that is at low cost. We can work with you and your district to provide that as well. But curricula has always been free. Online curricula is a different story during the pandemic because we weren't getting any core support, no hands-on. So our reagents, we weren't having revenue, in other words. So starting next year, our curricula will be free. Our reagents and equipment will be on a service charge, and a professional development is usually free too. And you get a stipend, usually.
I'll just add, we have a sliding scale model. We will work with you if, our primary focus of our service is schools that don't have access to these materials. So we will write our own grants to provide those resources to those schools for free. We will work with district admin to write grants so that the schools can grant fund them. So for example, the Strong Workforce program throughout the state of California, funded by the community college system, we work with district administrators in San Francisco, in Contra Costa, in Alameda, in Napa, and in San Mateo County to help them write proposals to get statewide grant funding that then went and allowed the districts to support our programs. So we provide data, we provide letters of support, we provide grant narratives. So we collaborate on fundraising with LEAs, local education agencies. And then I will say that although we do charge a nominal program fee for some of our materials, not all, the true cost is highly subsidized because we are a charitable nonprofit. We get donations from philanthropy, from industry, and we pass on those savings. So the actual charge for a program fee, more or less, depending on the sliding scale, is about 1/3 of the true cost that it takes to create these products. So we're not making a profit. We're a nonprofit, and we subsidize the services so that they can be delivered at no cost or free to schools. That is why we exist.
All right, we have just one more minute left. So if anybody in the audience has another question, feel free to type it now. We are getting thank yous coming in. All right, well, I will use the last moment to remind everyone that if you jumped in later and missed the beginning portion of this talk, we will have all the recordings from all of these breakout sessions available on the Whova platform. And also we will have, contact information of all of the speakers as well. So I will thank Kristen and Yingsu very much for your time and expertise and for sharing with us what you've been working on. And with that, we will wrap up this session and thank both our audience members and our speakers. And another session will be starting very shortly. So take care, everyone.
Thank you.
Thank you.